Welcome to The Explainer. Today, we're going to tackle a huge challenge in the world of AI. How do you actually run a smart, self-updating coding agent 24/7 without it turning into a total maintenance nightmare? Well, we're diving deep into an open-source project that does exactly that on AWS, and it uses a really powerful approach called declarative infrastructure.
Okay, so let's just jump right in. This quote, it's pulled directly from the project's core personality file. And honestly, it tells you everything you need to know about the vibe. We are not talking about some simple chatbot here. We're talking about AI agents with a serious and, let's be honest, very specific personality inspired by the Terminator.
So here's our game plan. First, we're going to meet these very unique agents. Then we'll get into the weeds of the big problem they're trying to solve. After that, we'll break down the really elegant two-layer architecture, dive into how the infrastructure and secrets are managed, and finally, we'll talk about why this whole declarative pattern is such a game changer.
All right, so first things first, what exactly are these clawdinators we're talking about? Think of these as full-blown, maintainer-grade AI assistants. I mean, they're actively watching GitHub, responding to people on Discord. They even have a hive mind, so they can share context and learn from each other's actions. Oh, and they can write and execute code, and get this, they can even modify and redeploy themselves. It's all powered by two different AI models, OpenAI for the heavy lifting on the coding side, and Anthropic's Claude for that brutal, Arnold-inspired personality. And yes, you heard that right, they post a lot of Arnie GIFs.
This all sounds pretty incredible, right? But running a sophisticated service like this around the clock, well, that's a massive engineering challenge. Let's break down why this is actually so tough to get right. You know the traditional way of managing servers, right? It's usually manual, and because of that, it's incredibly fragile. You SSH into a machine, you tweak a file here, install a package there, and over time, all those little manual changes add up. That's what we call configuration drift. Before you know it, you've got these unique, one-of-a-kind snowflake machines that are an absolute nightmare to reproduce if they ever crash. So the clawdinators project has a really brilliant solution to this snowflake problem. It's all built around this core idea of two separate independent layers. And it really leans into a declarative approach. Instead of giving the computer a long list of steps to follow, you just describe the final state you want, and the system itself figures out how to make it happen. And this slide lays it all out perfectly. You've got the top layer, which is the clawdinator itself, all the unique application logic, the personality, the hive mind, all that stuff. And then you have the bottom layer, which is a generic, totally reusable foundation for running any Nixos application on AWS. This generic part handles the whole pipeline, the infrastructure, the bootstrapping, even the secrets.
So let's really dig into this generic foundation. It's guided by a classic DevOps philosophy that completely changes the game when it comes to deployment.
This quote just perfectly captures the whole approach. You don't give your servers cute little names and nurse them back to health when they're sick. No, you treat them like cattle. They are identical, they are disposable, and they are easily replaceable. If one has a problem, you don't waste time trying to fix it. You just get rid of it and spin up a brand new, identical one from the herd.
And this is what that philosophy looks like in action. It's a completely automated image-based assembly line. A raw nixOS image gets built, uploaded to S3, and then turned into a bootable Amazon machine image, or AMI. From there, new servers are just stamped out from that exact same image. The first time they boot up, they grab their final configuration and secrets, and then the agent just starts. The most important part? Zero manual steps.
So here's the crucial takeaway. The Git repository becomes the single source of truth for the entire system. Absolutely everything you need to build a brand new, fully working server from nothing is right there to find in the code. You never need to SSH in to tweak things. In fact, SSH is actually disabled by default.
Okay, but hold on. If everything is just sitting in a Git repo, what do you do about your sensitive data, like API keys and tokens? You can't just commit those to your code, right? So how does this pattern handle secrets?
Well, this is where a really clever tool called agenix comes into play. It's built specifically for Nix-based systems to solve this exact problem. It uses strong encryption that's tied to SSH keys, and that lets you check your encrypted secret files directly into your Git repository, completely safely and securely.
And here's the really secure part. Those secrets, they are only decrypted when the machine boots up, and they're placed into a temporary in-memory file system. That means they are never, ever written to the server's hard disk in plain text. If the machine reboots, they just vanish until the system decrypts them all over again.
And this system manages all the critical secrets the agent needs to do its job. The Discord token to log in, the API keys for its 2 different AI brains, and the private key it uses to authenticate with GitHub so it can watch over the code repositories.
Okay, so let's zoom out. Why is this whole approach so important? I mean, it's about way more than just running one cool AI agent.
You've got to see how this fits into the bigger picture. There are tools like Nix OpenClaw that lets you run these agents on your own machine, just to play around. But clawdinators, that's the next level. It's the full production-grade pattern for building robust, always-on infrastructure in the cloud.
And it really all comes down to these 4 principles from the project's philosophy. Let's call them the prime directives. 1. Be declarative first. 2. Absolutely no manual edits to your servers. 3. Use only image-based deployments. And 4. Build your systems so they can update themselves. That is a powerful recipe for building modern, resilient infrastructure for any complex service you can think of.
And that really brings us to the final big thought. This pattern isn't just for AI agents. It is a blueprint for a whole new class of systems that are fully reproducible, totally secure, and can manage themselves. So the real question is, if you can build and deploy something this complex with this level of automation, what's next?